Okay. Assalamualaikum and good evening. My name is Shafi Irfan bin SHAHRIMAN. I'm from University UPTM, and today I'm about to presenting my part of the project that is greedy algorithm. Okay, what is greedy algorithm? Well, it's the most straightforward design technique that always choose the best option without considering any consequences of the choice. It picked the shortest path available to reach the desirable result, which also make an irrevocable decision, which means once choices are made, the algorithm does not go back and reconsider it. So that means it's just only a one-time use algorithm. In relief root optimization problem, or should say RROP, it uses a strategy called nearest neighbor, which means it only considers its next immediate move to ask like, what is the absolute closest place I haven't visited yet? And it goes there without thinking about how the decision might affect the rest of the trip. Now, this is my Java program of the greedy algorithm. So how does it work? Well, at this code given in the image is a list of the 4 places the ship needs to visit, which is the class of my maritime route. The program assigns an index to each location, that is port A, port B is 1, while relief center C and relief center D is 3. The distance matrix holds the distance between each single pair of location, and this matrix is essential because the program needs to know the cost of traveling between any 2 points to calculate the total route length. Now the second part is the starting the route search. This section prepares all necessary variables before the program starts choosing the actual route. First, you need to find the total number of the location. Since since the location is n equals is a distance length, which means is distance length equals to 4. Then it sets the starting point of the route, which is point A, which means the ship must start and end the same location, that is point A. A simple checklist is to keep a track of which location the ship has already visited so it won't go to the same place twice, which is given the route of no list, and then it empty a list will store a final sequence of stop in and the order they are already visited. The third, the third step is the decision making loop. This code is a loop that repeats until the ship has visited all locations. And this loop will run 3 times since distance length is equal to 4. Each time it runs, it finds and chooses the new unvisited location to add to the route. The search phase then checks every location on the map to see if it is the best option. After the search is complete, it will officially move the ship to the next location that was chosen in the loop. Now the final part of the Java program is the finalizing the route and output. This section performs the final task to complete its journey, which means the ship must return to the initial starting point, which is port A, to complete the relief mission. The route list is currently hold numbers in dozens like 0, 1, 3, and 2. This section converts those numbers into a readable location name, which is port A, port B, and any etc. And to run that set program, this code is the universal starting line for any Java application. When you execute it, the computer immediately look for and run the instruction inside the main method first. As you can see, this is the result of earlier, which is the greedy TSP route. Port A, and then you start with port A, and then you went to port B, and then you went to relief center D, and then to the relief center C, and then finally return back to the port A, which is the total distance amount of 88 km 88 meters. This is a critical algorithm started from port A and then it went back to the same place again. So that's all for today, and thank you for watching my presentation.
Hello and Assalamualaikum semua. My name is Muhammad HAIQAL bin Abdul WAHID. My student ID is AM2412018329, and I will be talking about divide and conquer algorithm. What is divide and conquer algorithm? A problem-solving strategy that breaks a complex problem into smaller, more manageable parts. It follows three main steps. First one is divide, break the problem into smaller sub-problems of the same type. Second is conquer, which is solve the sub-problem recursively. If they are small enough, solve them directly. For the third one, combine, merge the solutions of the sub-problems to get the solution for the original large problem. For Java program for divide and conquer, the first one is divide and conquer TSP. This is the main function that sets up the starting point for A and calls the recursive helper function. It creates the visited checklist, a boolean array. Then it marks our starting point, port A index 0 as true. Then it calls the helper function to start the real search from our starting point. Finally, it will return to the final minimum distance found by the helper. For the second one is divide and conquer helper. The purpose of it is recursively explores every possible path to find the minimum cost. For conquer, if all visited is true, the tour is complete. It returns the cost from the current location, which is both back to the start. For the recursive step, divide, if the tour is not complete, it loops through all locations. For each unvisited location, it sets visited I into true. Then it calls itself to find the best path from this new location. Then it adds the cost to get to I plus the results from the recursive call. It uses mathmin to keep only the cheapest total cost found so far. For the third Java program, we have all-visited method, which is a simple helper to check if the tour is finished. Its key action of all-visited method is to loop through the visited array. If it finds any false value, it immediately returns false. But if the loop finishes without finding a false, it returns true. Lastly, for divide and conquer, which is results and discussion. From our results, this method finds the guaranteed optimal solution, the optimal route, which is from port A to port B, to relief center D, to relief center C, then port A. The total distance of the route is 88 nautical miles. For the advantage of divide and conquer, it guarantees optimality, unlike greedy. This approach checks all possible permutations and will always find the absolute shortest route. For the disadvantage of it, it's very slow. This approach has an exponential complexity and it has a poor scalability. It's great for small locations but bad for large locations. That's all from me.
Hi everyone, my name is NUREEN BINTI AZHAR and I will be presenting the dynamic program solution for our RROP project. So our goal is to solve the traveling salesperson problem. We need to find the absolute shortest route for a ship starting at port A, visiting all other ports exactly once, and returning back to port A. My method is dynamic programming. Think of it as smart backtracking. It explores all possible paths, but it uses memorization, which is like taking notes to remember answers it has already calculated. This stops it from wasting time. Now, I'll quickly show my screen. This is the DP implementation. This helper method is the brain that uses memorization, and this controller method sets it up and boots the final path. As you can see, when I run the program, the DP method successfully finds the optimal route, which is the total distance is 88 nm, which matches the project requirements. So, what's the trade-off for this? The strength is that DP is guaranteed to be 100% optimal and it's much faster than brute force. The limitation is that it's complex to code and it uses a lot of memory for its nodes. In conclusion, DP is a powerful and accurate solution for this problem, which smartly trades memory for speed. That's all from me. Thank you.
Assalamualaikum and hi. My name is Muhammad FARIZ NAZMI and my student ID is AM241. Assalamualaikum and hi. My name is Muhammad FARIZ NAZMI and my student ID is AM24120182225. I am here today to present the backtracking algorithm. The backtracking algorithm is a powerful technique for solving complex optimization problems by systematically exploring possibilities and pruning non-viable options. The process can be broken down into 4 key components using vessel route optimization as an example. So first, we have the wrapper functions. It's initializing the search space. This is the starting point for algorithm. It prepares the vessel journey by setting up the crucial variables. It sets the shortest nautical distance to infinity. It initializes a special array to track all visited ports. It starts the vessel path at the initial port, and it then launches the exhaustive recursive search. Next, the base case, mission completion check. This condition is met when the relief vessel has successfully visited all designated ports. The condition is typically checked when the count of visited port equals the total number of ports. The total road cost is calculated by adding the final distance leg back to the starting point. If this nautical distance is lower than the current shortest distance, the optimal maritime route is recorded. Next, we have state transitions, recursive descent. This is the core logic where the vessel decides which unvisited port to sail next. The algorithm iterates over potential next ports. It employs pruning by immediately stop exploration of any route if the new accumulated cost exceeds the current shortest path. If the path is viable, the new port is marked as visited. The road path is updated and a recursive call is made to continue the journey for the new port. Finally, backtracking mechanism, state reset. This step ensures the algorithm can forget the last port and try a different route sequence, systematically exploring all options. It occurs after exploring the entire route branch originating from the port. The port visited status is reset to false. The path update is undone, allowing the search to consider all possible maritime routes. So, this systematic exploration combined with the efficiency of prunings make the backtracking algorithm a powerful way to solve complex optimization problems.
Now we'll be touching the subject of sorting and searching. Hi, my name is HAFIZUDDIN bin AMINUDDIN. My student ID is AM241201869. What are sorting and searching? Sorting, the process of arranging a collection of items into a specific logical order, for example, like numerical and alphabet. RROP application that use is organizing cargo by priority, destination, and expiration date. Next is searching, the process of finding the specific location of a target item within a collection. The RROP application applied is instantly locating specific supplies, for example, like searching for 200 units of antibiotics in the cargo hold. Now I'll be touching the subject of sorting, insertion sort. The code for insertion sort organizes an array of integers into descending order. How the code works: starting point, the algorithm begins its loop at the second element, index 1, of the array, assuming the first element, index 0, is already sorted. Next, it's picking the key. It selects the coded element key to place into sorted portions of the array. Code reference, integer key equal array. Comparing and shifting is the next step. It compares the key with the elements before it. If an element is larger than the key, the code shifts the element one position to the right to make space. Code reference, while j is bigger, equal 0, and n array j bigger than key. So the shifting addition you see is array j plus 1 equal array j. Next, there will be insertion. Once the correct spot is found or the start of the array is reached, the key is inserted. Code reference, array j plus 1 equal key. Next will be repetition. This process repeats for every element until the entire array is sorted. Next up is searching, binary search. The code for binary search finds a specific target number, for example 5, within the array that was sorted by a previous step. How the code works: defining the range, the code sets two pointers, low, start of array, and high, end of array, to define the current search area. Code reference: integer low equal 0, integer high equal array dot length minus 1. Next, we'll be finding the middle. Inside a loop, it calculates the middle index of code range. Code reference: integer mid equal low plus high minus low divided by 2. Next, we'll be checking the middle. It compares the value at the mid index with the target. After the match is found, if array mid equal target, the search stops and the index is returned. Next, we'll be narrowing the search. If the middle value is smaller than the target, array mid is smaller than the target, the code ignores the left half by moving the low pointer up. Low equal mid plus 1. If the middle value is larger, it ignores the right half by moving the higher pointer down. High equal mid minus 1. That's the code. The loop continues dividing the search area in half until the target is found or the range is empty. Now, let's discuss the advantage and disadvantage of using insertion sort and binary search. Based on my implementation, the code I use, let's start with insertion sort. Why did I use it? First, look at the code. It's incredibly simple, just a key and a while loop. This simplicity is its biggest advantage. It's easy to implement and debug, plus it's space efficient. It's stored in place, meaning I didn't need to create an extra array. For small lists like my example of 6 items is actually very fast. But it has a major disadvantage, scalability. The nested loop gives it quadratic time capacity. If I had to sort a real RROP inventory of 10,000 items, this would be very slow. It performs too many shifts. Then, we'll be looking at binary search. Its advantage is obvious, it's big. By cutting the search range in half every time, look at the code that I use, low equal mid plus 1. It achieves logarithmic time. It can search massive database instantly. However, it has a critical disadvantage. It requires sorted data. You can't just run binary search on a raw list. You must pay the cost of sorting it first. After, it's harder to update. Adding a new item means resorting and shifting everything to keep order. So basically, you need insertion sort first, then you can do binary search. Conclusion for RROP. Sorting conclusion. Insertion sort is fine for the small sample. A real RROP system with a large inventory would require a faster sort, like merge sort, to be efficient. Searching conclusion. Binary search is the clear choice for RROP. The one-time cost of sorting the inventory is worth the massive repeated gains in search speed for logistics.